All right, we got day 2 of the 5 for 5 here. So this is question 1, AB1. We've got the graph of f prime here, the portion of the graph of f prime, the derivative of the twice differentiable function f is shown in the figure above. The area of the regions bounded by the graph of f prime and the x-axis are labeled. It's known that f of 1 is equal to -2. So we might need to use that, and it's easy to lose that. Now we might not need it in question 1 here. It might be a question, 2, 3, 4, or 5 that we'll use that for, but I bet we'll use it. So let's go ahead and look at the rest here. We've also got a table. The function g is twice differentiable. The selected values for g and g prime are shown in the table. Now we might not use both of these for question 1. For question 1, find all values of x in the open interval from -3 to 8 for which the graph of f has horizontal tangent lines. For each value of x, determine whether f has a relative, and they spelled that wrong, but a relative min, a relative max, or neither a min or a max. Justify your answer. So we're talking about f, and what this gives me here is f prime. So if we want horizontal tangent lines, we know f will have horizontal tangents when the derivative is 0. So when f prime of x is equal to 0. So that's the start. Find all values of x for which a graph of f has horizontal tangent line. So we're looking for when the derivative or this graph here is equal to 0. We can include -3, but it says in the open interval, so we're not going to include it because -3 is not included there. So we're going to go with 1 and 6. So that's part of my answer here, and then there's more. It also says, for each value of x, determine whether it has a relative min, relative max, or neither. So at x equals 1, that's one of the spots here, we can see that the derivative is changing from positive to negative. So we can say f prime changes from positive to negative. Okay, so if you think about f prime as the slope, if the slope is changing from positive to negative at that spot, that's going to be a relative maximum. So therefore, a relative maximum. And that's the same as a local maximum. We just use the words that they're using at x equals 1. Okay, same idea with x equals 6. So you go look at x equals 6, and you can see that the derivative is changing from negative to positive. So we would write that here. F prime changes from negative to positive. So if the slope is changing from negative slope to a positive slope, we're going to have a relative minimum at x equals 6.